Okay, so let's talk about what's really running the show inside your computer, your phone, pretty much everything you use. We've got two processors at the heart of it all, the CPU and the GPU. You can think of one as the brain and the other as the muscle. And honestly, once you get the difference between these two, you'll understand so much more about the tech that powers our world. So yeah, let's just dive right in.
To really get this, let's start with a simple question. Imagine you're opening a restaurant. Now you have a choice. Do you hire one brilliant, incredibly versatile head chef? Someone who can cook anything to perfection, but they can only do one dish at a time. Or, option B, do you hire an army of, say, 1,000 assistants? Each one is trained to do just one simple thing perfectly, like chopping carrots, and they can all do it at the exact same time. So, which do you choose? Well, it really depends on what you're trying to cook, right?
And that idea right there, that's the whole key. Your CPU, that's your head chef. A true master of all trades, juggling complex and different tasks one after another with incredible speed. And the GPU? Well, that's your army of assistants. They're specialists who can tackle thousands of simple, repetitive jobs all at once. Just keep that analogy in your head because it basically explains everything we're about to cover.
All right, first up, let's meet that head chef, the brain of this whole operation, the central processing unit, or as we all know it, the CPU.
The CPU really is the most critical part of any computer. It's not just a processor, it's the manager, the boss. It takes in all your inputs, it sends out all the instructions, and it oversees everything the system does. And its defining feature, it does things sequentially. That means one task after another, in a super logical, organized order.
So, what does this actually mean? It means a CPU is built to be flexible. It has just a few but extremely powerful cores that run at ridiculously high speeds. This lets it switch between all sorts of different tasks on a dime. It runs your operating system, your web browser, it even tells the GPU what it needs to be doing. It's the essential do-it-all brain.
Okay, so if the CPU is the brain, let's get to know the specialized muscle, the GPU. And this thing is built for one purpose, really: heavy lifting.
So the graphics processing unit, the GPU, actually started out with a pretty specific job. It was all about rendering the graphics for video games and animations, but developers pretty quickly realized that the way it was designed for that job made it unbelievably powerful for a whole bunch of other stuff too. And its secret weapon? Something called parallel processing.
And this is where it gets really interesting, because the biggest difference between them isn't just their jobs, it's written into their DNA. It's all about how they are physically built to do what they do.
Just look at this. This image basically tells the whole story. On the left, you've got the CPU architecture with its few, big, powerful cores. Those are our head chefs. And then on the right, you have the GPU, which is just this massive grid of thousands of smaller, simpler cores. That's our army of assistants. This isn't just a minor tweak. It is a completely different philosophy of how to build a processor.
And we're not just talking about a couple of extra cores here. Modern GPUs have hundreds, and very often thousands of these simple little processing units packed inside. And this is the source of their power. It's brilliant, really. A GPU takes a gigantic problem, like, say, rendering millions of pixels on your screen, and it shatters it into thousands of tiny, identical little tasks. Then, it just assigns one of those tiny tasks to each core, and they all solve their piece of the puzzle at the exact same time. So, instead of one chef cooking a 1,000-course meal, one dish at a time, you get 1,000 cooks each making one dish all at the same instant.
So we have a versatile brain, and we have a powerful muscle. Why has this difference suddenly become one of the most important things in all of modern technology? Well, it's because the GPU's unique design accidentally created the perfect engine for the AI revolution.
The reason is actually pretty simple. Training an AI model means doing millions and millions, even billions of repetitive math calculations. It is the ultimate army of cooks kind of task. And that parallel architecture of the GPU, which was first designed for pushing pixels around, well, it turned out to be absolutely perfect for the kind of math that makes machine learning work.
At its core, training an AI is just a simple loop that repeats over and over and over again. It makes a prediction, it checks to see if it was wrong, and then it adjusts itself to be better next time. A CPU would have to do that one step at a time, which would take forever. But a GPU, it can run thousands of these learning cycles all at once, in parallel. That's what makes modern AI even possible.
And the results of this GPU-powered revolution, they are literally everywhere.
I'm talking about the voice assistant on your phone, the movies that Netflix recommends to you, the chatbots you talk to for customer service, fraud detection at your bank, and even the development of self-driving cars. All of these things are possible because of the massive parallel processing power of the GPU.
So, when you boil it all down, which one is actually better? Well, like we said at the start, that's not really the right question to ask. The real key is understanding which tool is the right one for which job.
This table here really just sums it all up perfectly. The CPU, with its few powerful cores, is built for that fast, one-thing-at-a-time processing that you need for just general computing. The GPU, with its thousands of simpler cores, is built for the massive parallel processing needed for things like AI, big data, and of course, high-end gaming. One is the universal tool, the other is the specialized powerhouse.
So, if there's one thing you take away from this, it should be this. It's not a competition, it's a partnership. The CPU is the manager that's directing the whole workflow, and the GPU is the massive workforce that it calls on to get those huge, repetitive tasks done. The head chef is still running the kitchen, but they rely on that army of assistants to get the really big orders out the door.
But the story definitely doesn't end here. The lines between these two processors are actually starting to get a little blurry. We're seeing CPUs get better at parallel processing and GPUs become more flexible. And that leaves us with a really fascinating question for the future. What's the next generation of processors going to look like when it combines the best of both of these worlds? What will it be capable of then?